Hey everyone, and welcome back to another episode of Hey Sidewalk Scientist. I'm Alex Martin, the founder of Experience De Leona and the host of Sidewalk Science Center here in Bradenton and Sarasota, Florida. We have another great question that was asked at Sidewalk Science Center actually back on October 17th of 2020. And the question goes, why does Jupiter look bigger than Mars in the telescope if Mars is closer to Earth than Jupiter? So this is a really cool question, because Jupiter is somewhere around 400 million miles away from Earth when Earth and Jupiter are at their closest points to each other, whereas Mars tends to be somewhere anywhere from 35 to 40 million miles away at its closest point. But even at its closest point, as we just saw last October, in October of 2020, Mars looked really small in the telescope when Jupiter looked pretty big in comparison. And they were pretty close to each other, so you could actually move the telescope back from one to the other, and there was a clear difference in size. So what this actually comes down to, it's, there's nothing funky going on, there's no lensing effects happening, nothing with the telescope that we're making smaller. It's just simple geometry. So let's get some numbers here. Mars on average is about 140 million miles away from Earth. That's on average. But back on October 6th of 2020, Mars was about 38.5 million miles away from Earth. But then when Mars is farther away from Earth, it can be more than 200 million miles away. So going from 38.5 million all the way to 240 million miles, that's a huge variation. That's a big percentage change in the distance from Earth to Mars. However, Jupiter is really far away from Earth. It's already way back here. So when Earth and Jupiter are at their closest points in their orbits to each other, it's a small change. The difference from their closest points to their farthest point is a much smaller percentage than Mars and Earth's closest and farthest points away from each other. So in terms of distance, Jupiter is about 3.5 times farther away from Earth than Mars is. However, Jupiter is also about 20.5 times larger than Mars. Jupiter itself is about 86,000 miles in diameter, whereas Mars comes in roughly at about 4,000 miles in diameter. Mars is just about half the size of the Earth. So when you do the math, you actually find out that at their average points, if you're looking at Mars and Jupiter at their average points and their average distances away from the Earth, Jupiter comes in at about 5.8 times larger than Mars in diameter, the apparent diameter. So how large each planet looks in the telescope. However, at Mars's closest point to Earth, Jupiter will only look about 1.64 times larger than Mars. Because there's such a big swing in Mars's distance, that variation changes. So even though the average size difference between Mars and Jupiter is about 5.8 times, when Mars is really close to Earth, that shrinks down to only 1.64 times larger. But then when we look at Mars at its farthest from Earth, Mars shrinks down to nothing but a speck. And here in March of 2020, we're about 5 months away from Mars being on the exact opposite side of the Sun from Earth. So as we're getting closer to that August point in time when Mars is kind of entering the glare of the Sun and we won't be able to see it anymore, if we do the math, we'll find that Mars will appear about 10.5 times smaller than Jupiter. Jupiter goes from being 1.64 times larger than Mars, so not too much, all the way to 10.5 times larger than Mars. That's, if Mars was this big, Jupiter would appear as this big. It's huge. It's a huge change. So let's use these to kind of show exactly what we mean. So let's say that the camera right there is Earth. So Jupiter is way back here. It's about 3.5 times farther away from Earth than Mars is. So we're roughly somewhere in the right area. So this, you can see that Mars right here, the farther away Mars gets, the smaller it appears relative to Jupiter. But then when Mars is really close, you can see that it's taking up much more area compared to the surface of Jupiter. If I move this really close, it suddenly becomes really big against Mars. If I move Mars even closer, it becomes really big against Jupiter. So this is all about the perception. This is actually acting in a cone shape, where the edges of the cone are kind of coming directly around the edges of the planets when you measure it, so that angle change is really wide, and then the angle change is really skinny. So this is why it appears to get really big and really small, whereas Jupiter, the variation is not as much. Thank you all for watching this episode of Hey Sidewalk Scientist. I just want to give a big shout out to our patrons over on Patreon who are helping to support programs like Sidewalk Science Center and our at-home programs, and even being able to make videos like these. If you'd like to support us, you can visit www.patreon.com/experience for as little as $1 a month. And remember, if you support us for $5 or more per month, we will donate a science kit to a kid who participates at Sidewalk Science Center. Thank you for watching this video, and as always, here's to all your endeavors, because we have a future to create.